Hello, class 11th physics, kinetic theory of gases, and this time I have chosen this small topic but very much important, and in upcoming videos it has so much significance: degrees of freedom of a gas molecule. So degrees of freedom are the total number of axes which are required to specify motion of a molecule, or in other words we can say that these are the independent ways in which molecule can store energy. So we will focus on a total number of specified axes in which motion of that molecule can be specified. So if we talk about this monoatomic gas particle, so I would not say it a molecule, but it's an atom, gaseous atom. So it is a point particle, and this in this point particle, three translational axes are specified: x-axis, y-axis, z-axis. So x-axis, y-axis, and z-axis, three linear axes are there. But there are no rotational axes for point object. Rotation is not specified. See, I'm rotating it, but we can't see any rotation. See? So actually it does not consist any energy for rotational motion. So only motion it only energy it can store in the form of translational three axis. So its degrees of freedom denoted by F is denoted by small f. For monoatomic it is 3. Now for diatomic. Now for diatomic molecule, it can have motion along x-axis, y-axis, and z-axis. Other than that, it can rotate about this axis or this axis. Means two rotational coordinates are also there. But so there is no rotation specified along an axis passing through its length. So there are total number of degrees of freedom, 3 translational and 2 rotational. Total 5 coordinates are there. Now triatomic. Well, triatomic or polyatomic. In triatomic, actually a linear molecule is possible, but mostly non-linear molecule. We consider non-linear molecule. So what I am going to draw is or what I am going to demonstrate is a non-linear molecule. So now in triatomic or polyatomic, planar molecule, non-linear molecule, translational, x-axis, y-axis, z-axis. Other than that, rotational. So it can rotate about this axis, it can rotate about this axis, and it can also rotate about this axis. So there are 3 rotational axes. So total number of degrees of freedom are F equal to 6. So why do we study degrees of freedom? First thing, it gives us an information that in which parts, which forms, or in how many ways molecule can store energy. First thing is that, and second, which is most important thing, that all the energy, or to be very precise, kinetic energy possessed by a molecule distributes get distributed equally in all the degrees of freedom. It means if it has this molecule has some energy, let us suppose 10 units, then each of its degree of freedom will have 10 by 3 units of energy, and same for others. So this law is called equipartition of energy. So it is just simply a law which states that the energy possessed by a molecule divides or get distributed equally in its all the degrees of freedom. So I'm ending this video here, and we will apply this information to calculate specific heat capacities and more. So stay tuned.